Okay, so I looked at the video and found out that I made a mistake and I was talking too softly. So hopefully I can get through this and finish the recording. This section here is for the processing of the logs and sand. The output that I'm looking for is gunpowder. Gunpowder requires charcoal, sulfur and niter. Now niter is able to be produced from sand, not directly from sand but sandstone. So in order to produce niter, I need to auto-craft the sand into sandstone. Sandstone goes in, gets pulverized, and hopefully as a byproduct produce the niter. The primary product of pulverizing sandstone is 2 blocks of sand. You'll see that 2 blocks floating through this Buildcraft pipe. So obviously the production of niter isn't very high. So in our little buffer here we've got a full row of sulfur and a row of charcoal. Charcoal being the most productive product of our farm. So in order to get the sulfur we simply have to pulverize some netherrack. However, the primary produce of pulverizing netherrack is cobblestone. The secondary is, as you can see here, a piece of sulfur floating through this Buildcraft pipe. Now when this buffer has a full stack of sulfur, it obviously turns off the pulverizer. Turning off the pulverizer in turn stops the flow of netherrack into the pulverizer. Now from the cobblestone that you see here, it goes into the pulverizer, and the 2 products are sand and gravel. Sand being the primary product and gravel being the secondary product. Gravel in itself is pretty useless, so what I do is I convert it into flint by pulverizing it. It produces 1 piece of flint for every piece of gravel. Flint in itself can be used, but I would much prefer to pulverize it into some tiny piles of flint dust. I can auto-craft the tiny piles of flint dust into flint dust itself, and from it I can gather the product I need in order to make silicon. Now, in order to power all of these pulverizers, I use Stirling engines, which burn charcoal. Now, burning charcoal obviously uses some of it in order to fully stock up the pulverizers with energy like you see here. Okay, so keeping those pulverizers going isn't really taxing, even though I've got about 14 Stirling engines there. So whatever is left over gets sent over here. This is an array of 32 Stirling engines. Each one of them is fed charcoal. From that charcoal we produce megajoules, up to 32 megajoules, which gets fed into these, or which powers these magma crucibles. Magma crucibles being fed netherrack through this chest here and through this filter. The filter then pushes the netherrack into these magma crucibles. Magma crucibles, these 3 feed 4 thermal generators, which then charge up these batteries, these bat boxes, the industrial craft batteries. Okay, so let's go over here. As you can see, as a backbone of all this, the megajoule combustion engine power generation plant, whatever you want to call it, serves as a backbone to power the majority of the Buildcraft engines and machines that you see here. The array I've got here produces a full 80 megajoules per tick, since each one of these combustion engines produces 5 megajoules per tick. These engines require biofuel and water as a cooling agent. I have seen previous designs of this where the cooling system was inadequate to keep these engines cool. This system is designed so that even if in sustained cases where these engines are running all the time, they are being supplied enough water to keep all of them cool. Having said that, however, I also have engine protection system. Whenever any one of these engines turns red, it enacts the engine protection system, which is basically some red some red pipe signal, which basically will turn off this redstone signal. Turning off this signal will in turn turn off the red pipe signal. Now, in order to turn the engines on as a requirement, we only require the engines on when these redstone energy cells require power. As you can see, currently they do require power, so this blue signal wire is on. Now, these engines will heat up and require a bit of time at 0 temperature in order to restart. You'll probably, if I wait around here long enough, see that these engines will start up again. Here we go. So they don't start up straight away, and once they get up to temperature, they can actually take a fair while to cool down. Maximum heating temperature is 49,000 degrees Celsius. So when it reaches maximum temperature, it requires a bit of time at 0 in order to restart, but they will restart on their own. This system is designed to pump 80 megajoules into these two systems. So these redstone energy cells will have a maximum input value of 40 each. So they'll load share nicely. I have 2 of them because every once in a while this might reach full capacity and turn off too soon. It'll just flicker. Whereas the 2 of them together, both of them have to have full charge in order to turn the engines off. So you can see there the engines are turned off again, because these have reached the maximum. Now, maximum output of these each is 60 megajoules. Now that's okay, because not all these subsystems will require power all the time. This subsystem here is for the farm. It will sometimes require power, but like now, it won't. So during the times of downtime, it will receive power, but not put any power out. Actually, this is probably too high. 65 megajoules will do. This is the biofuel production. I do have a maximum input here of 100, but that's not really required because we can only get. No, we can get. What's the maximum power here? So maximum power is 60 megajoules. So we could get a total of 120 megajoules, which we probably never will. So the biomass production, which is the two fermenters, will only require a power output of 10 megajoules. So the biomass requires 20, biomass produces requires 10, the biofuel requires 20. And each one of these, this is the apple if you remember, the apple system requires only 5, and the logs only require 5. So, being night time, I'm going to go to sleep, and hopefully this will end the recordings for tonight.